In this video, we're going to do a few extra examples computing inverses for matrices. So let's start with a couple of 2 by 2 examples. So here's A. It's a 2 by 2, okay, so it's square, so it could have an inverse. Because it's a 2 by 2, there is the formula. Okay, so we could compute it that way. So we'd first want to start by computing capital D, which is -2 times 7 minus -3 times 4. So that's -14 plus 12, so -2. And then A inverse is going to be 1 over capital D, and then times the matrix where we switch the main diagonal. So the 7 and the -2 switch, and we negate the other entries, but leave them in their same spots. Okay, so that is 1 over -2, 7, -4, +3, -2. And then when I divide everything by -2, I know that A inverse is -7 over 2, 2, -3 over 2, and 1. Okay, so that's the A inverse that I'm expecting. I'm going to also do this using Gauss-Jordan method, so we can practice that. Okay, so this I want on the side. So when we're doing Gauss-Jordan method, we take A and we augment it with the identity of the same size. And then we just row reduce like normal. So we're going to start in the top left corner, and I want to pivot around that entry. So I'm going to take row 1 and divide by -2. So that's going to give me a 1, a -2, -1/2, and 0. Okay, so then I'm still pivoting around that entry. So I want to change row 2 by adding 3 of row 1. So this one's going to be a 0. 7 plus 3 times -2, so that's 7 minus 6, that's 1. 0 plus 3 times -1 is going to be -3 over 2. And this one is still a 1 because I'm going to add 0 to it. So now I move down, I'm now pivoting here. It's already a 1, so that's nice. So I just need to do row 1 plus 2 of row 2. Okay, so this is still going to be a 1. This one's now going to be a 0. So now I have, maybe I'll just write it in green here. So I'm going to have -1/2 plus 2 times -3 over 2. So that's -1/2 minus 6 over 2, which is -7 over 2. And then I have 0 plus 2, that's 2. So once we get to this step where we have the identity on the left, the thing that remains on the right is the inverse. Okay, so here A inverse is the matrix -7 over 2, 2, -3 over 2, and 1. Okay, same as above. So we can be sure that we did it right in both cases. Okay, let's try another one. Again, if we use the formula, so I start by computing D, it's going to be 1 times 4 minus 2 times 2, which is going to be 4 minus 4, or 0. Okay, D cannot be 0, so D equals 0 means that B inverse does not exist, because in the formula I'd have to divide by D, which I cannot do when it's 0. Okay, if we're using the Gauss-Jordan method, what would we see in order to know it didn't exist? So I take B and I augment with the identity of the same size. Okay, we're pivoting here, so I'm going to do row 2 minus 2 of row 1. Okay, so row 1 stays the same. So then this one's going to be 0. Okay, 4 minus 2 times 2, that's also 0. 0 minus 2 times 1 is minus 2, and that one's going to be a 1. So I'm done pivoting in this column. I move down and over. I want to pivot here. Okay, but this is a 0. So what that means is that we cannot get I2 on the left. So we cannot row reduce to get the identity or diagonal form there. So that's another reason why B inverse does not exist. Okay, let's try a 3 by 3 example. So we want to find A inverse if it exists. So here's our A. So we're going to take this A, okay, and augment with the identity of the same size. So that means I'm going to have a 3 by 3 identity this time. But again, I just row reduce like normal. Okay, so this is, oops. I want to pivot around that entry. It's already a 1, so that's nice. So I want to make the 2 in row 3 a 0. So I'm going to do row 3 minus 2 of row 1. Okay, so this is going to be a 0. Now I have 9 minus 2 times 2, so minus 4. That's going to give me a 5. 2 minus 0 is still a 2. This is going to be a negative 2, a 0, and a 1. So now I want to move down and over, and I'm going to pivot around this entry. So I first want to take row 2 and divide it by 3. So I'm going to get a 1 here, a 1/3 here, and a 1/3 here. Everything else is the same. Okay, we're still pivoting around that entry. So now I want to do row 1 minus 2 of row 2. Oops. Okay. So this is still a 1. This is now going to be a 0. So 0 minus 2 times 1/3 is going to be minus 2/3. This one is still a 1. This one is also going to be a minus 2/3. And then I'm going to have a 0 here. And then I'm going to do row 3 minus 5 of row 2. So I have a 0, and then I have 2 minus 5/3. So that's actually a 1/3. Negative 2 minus 0. 0 minus 5/3 is minus 5/3. And then I have a 1. So now I move down 1 over 1. I want to pivot here. Okay, it's not 0, so that's good. So I can make it a 1 by doing 3 of row 3. So this is going to be a 1 now. This is going to be a negative 6, a negative 5, and a 3. Okay, and then we just fill everything else in as it was. Okay, now I'm still pivoting around this 1, so I want to make the other things 0s. I'm going to move down again so that I have lots of room. Okay, so I want to do row 1 plus 2/3 of row 3. Okay, so I'm not changing row 3. Okay, so here this is going to be a 1, a 0, and now this is going to be a 0. So I have 1 minus 2/3 times negative 6. So that's actually 1 minus, here maybe let's write these out. Okay, so this is 1 plus 2/3 times negative 6. So that's 1 minus 4. Okay, so I'm going to get a negative 3 there. Okay, in the next spot, I used to have a negative 2/3, and now I want to add 2/3 times negative 5. So that's negative 2/3 minus 10/3. So that's going to be negative 12/3, which is actually a negative 4. Okay, now 0 is a bit easier. So 0 plus 2/3 times 3, that's actually going to be a positive 2. Okay, I also want to do row 2 minus 1/3 of row 3. So that's going to give me 0, 1, 0 here. Maybe I'll do these in a different color. Okay, so in the first, well, the first spot was a 0, so maybe that one's not so bad. So it's 0 minus 1/3 times negative 6. So that's going to be a positive 2. Okay. The next spot used to be a 1/3, and now I want to subtract 1/3 times negative 5. So that's 1/3 plus 5/3. So that's going to be 6/3, which is a 2. And then I had a 0. So 0 minus 1/3 times 3, that's just going to be a minus 1. Okay, so I have the identity on the left. So the thing on the right is the inverse. This was called A. So that means that our A inverse is going to be negative 3, negative 4, 2, 2, 2, negative 1, negative 6, negative 5, 3. So that's our inverse. If you wanted to check that it works, I'm not going to do it, but you could do A times A inverse, and you should get the identity size 3, or you could do A inverse times A. Okay, either or both of those. You should get the identity either way. Okay, that's the definition to be inverses. So again, you can check your answer.